All right. Welcome, folks. Welcome into our Co-opting AI space. We are so excited to have you on this last event in the year 2024. My name is Mona Sloane. I am a sociologist of artificial intelligence. I'm the host of the Co-opting AI series and assistant professor of data science and media studies at the University of Virginia, where I run Sloane Lab, which is a group that looks at the implications of AI for the organization of social life. We had a very busy year with Co-opting AI, a wonderful year. We were able to strengthen the very productive and positive relationship between Sloane Lab and the Digital Technology and Democracy Lab at the UVA Karsh Institute of Democracy and the NYU Institute for Public Knowledge. We held 6 events with terrific guests who spoke on topics as varied as campaigning, crime, math, architecture, and anatomy. By the way, you can watch all of the Co-opting AI events on YouTube, going back to when we first started in 2019. As we bring this busy year to a close, I want to underscore my sincere gratitude to our team who really work tirelessly behind the scenes to make these conversations happen. Big thanks to IPK. Big thanks to the Karsh Institute of Democracy. I also want to thank my wonderful guests who bring their expertise and energy to the Co-opting AI space, and to you, our wonderful audience. You always ask very pointed, critical questions that really enrich our conversations. Now, today, we are talking about a kind of AI that most of you are probably, at least in some way, are intimately familiar with, the kind of AI that goes into cars. But before I kick off that conversation, I want to acknowledge that the land where we at UVA learn and work is the homeland and traditional territory of the Monacan Indian Nation. As UVA, we pay respect to the elders and knowledge keepers, past and present. We also acknowledge and pay respect to the enslaved Africans, enslaved laborers, and free Black laborers who built UVA, as well as their descendants. Today, we acknowledge the land, we acknowledge labor, traditions, and knowledge, and we acknowledge lives. Now, transportation as a social process really enables citizens to participate in democratic processes by quite simply providing somewhat equal access to public spaces, to resources, and to civic engagement opportunities. Getting from one place to another is kind of our social glue. Now, privatized mobility in the form of cars has long been in tension with the notion of public transport as infrastructure for democracy. And the advent of autonomous driving has not only turned the automotive industry into an AI industry, or at least software industry of sorts, it also has once more put car culture at the center of how we talk and think about the mobility of the future. Today, we will provocatively ponder whether AI-enabled cars may be the antithesis of publicness and democratic engagement. I am very excited to welcome my guests today who are truly uniquely positioned to do some pondering with us. Please join me in welcoming Nathaniel Chodosh, Melissa Cefkin, and MC Farrell. Kicking us off today will be Nathaniel Chodosh, who is an assistant professor in the Department of Computing Sciences at Villanova University. His research focuses on computer vision and specifically on autonomous driving and LiDAR-based sensing. He's particularly interested in analysis by synthesis, the machine learning approach wherein inferences are made by comparing hypothetical world states produced by a world model to actual measurements. His work has been published at some of the most important venues in the field. He received his PhD from the Robotics Institute at Carnegie Mellon University, and before that, he received his BSc from the University of Pennsylvania. He has worked in the past on research with Argo, who are now Latitude AI, and the Pittsburgh Pirates. Welcome, Nathaniel. Following Nathaniel will be Melissa Cefkin, who is a lecturer in general engineering at Santa Clara University, specializing in social and behavioral research, humanity-centered design, and advanced technology innovation, particularly AI and automation. As an anthropologist, she collaborates with engineers and scientists on autonomous vehicle development, focusing on the social, ethical, and interactional aspects of vehicle behavior and signaling. Melissa also studies labor, organizational dynamics, and enterprise work technologies, and she applies ethnographic methods to understand work practices and systems. Her career includes leadership roles at Waymo, Nissan-Renault, IBM Research, and Sapient. She has been pretty active in academia through teaching, through publishing, and mentoring students at San Jose State University and California College of the Arts. She also has a Fulbright, or had a Fulbright, and she co-founded the Ethnographic Praxis and Industry Conference, the EPIC Conference, and has served on committees for the National Science Foundation and the National Academies of Science. Welcome, Melissa. It's great to have you. Lastly, closing us out today, and for the year, may I say, will be my colleague, MC Farrell, who is an assistant professor in engineering and society at the University of Virginia's School of Engineering and Applied Science. Their research explores the intersections of law, technology, and culture with a focus on materiality, sustainability, and resistance. Currently, they examine software-enhanced automotive technology and its implications on repair, maintenance, and modification, delving into repair labor, aftermarkets, and legal issues affecting these areas. They earned a PhD from USC's Annenberg School, where their dissertation analyzed how copyright laws challenge car repair communities. MC has held a Cornell Presidential Postdoctoral Fellowship at Cornell Tech and holds an MA in Media, Culture, and Communication from NYU and a BS in Film, TV, and Radio from Boston University. Past work includes studies on credit default swaps, interactive media, and broadcast diversity policies. I am so excited that you all are here. Thank you so much. Welcome. We'll have a great conversation. And with that, Nathaniel, I'm going to pass it on to you. Welcome, everyone.
Hi, let me just get started with the slides. Okay. Yeah, so thank you so much for that introduction. So like was just said, I received my PhD from the Robotics Institute at Carnegie Mellon, where I was a part of the Center for Autonomous Driving that was sort of like created and funded by this autonomous driving company, Argo AI, which is now Latitude AI inside of Ford. So this center was created right as I was beginning my PhD, which coincided with the first sort of big wave of hype around self-driving cars around 2017. And the feeling in the air, as I remember it at that time, was that, you know, in a couple years, everyone's car is going to be driving itself across country. So I have here a headline from Wired in 2016 that Elon Musk says every new Tesla can drive itself. And in that article, he's quoted as saying, you know, your Tesla will pick someone up from their home in LA and drop them off in the bright lights of Times Square. So obviously that didn't happen. But you can now hail a self-driving taxi from Waymo in select areas of Los Angeles, Phoenix, and San Francisco, I think are the current areas. So we're kind of in this strange state where in some sense the hype did come true. There are autonomous vehicles out on the road right now, but maybe not in the most exciting way that people had hoped for. So my goal for the next few minutes is to just lay out the basics of how autonomous vehicles work, and in doing so, call out some technical problems some research problems that make the difference between, driving around a California downtown, and your Tesla driving you cross country. And also call out maybe some of these ethical issues. Now, that's not my expertise. I'm not an expert in the intersection of society and autonomous vehicles, but you can't help but notice things when you work in this space. And so I'm really excited to talk to the other panelists and the audience members about these things. So all right, let's get going. So this is the traditional robotics pipeline as applied to autonomous vehicles. From left to right, we have sensing, perception, planning, and control. In short, an autonomous vehicle first takes physical measurements of the world using sensors. Those measurements are then synthesized into perceptions, like the position of all the other cars of the road. And then those perceptions are used to plan the future trajectory for the vehicle, which also includes predicting the motions of other actors. And then finally, that motion plan is sent to a control algorithm, which figures out, how much do we turn the wheel, how much do we step on the gas, that sort of thing, to actually execute the plan. And these steps are run in a loop, so the vehicle is constantly perceiving the world and updating its plan. And we're going to dive into really just the first three of these, because that's really sort of the AI component of these things. The control is, maybe mathematically very interesting, but not as on topic for today. So we're going to dive into the first three of these, and in each one, I'm going to try and bring up maybe some interesting challenge that we can talk about. Okay, so sensing. So I'm just going to give an overview of sort of the normal sensors that are on an autonomous vehicle. I'm going to use that example for everything today. The company that I worked for, Argo AI. So the main sensor that's on an autonomous vehicle is a bunch of cameras. So this one had 7 cameras arranged in a ring on top of the vehicle, as well as 2 more cameras that were parallel to each other and facing forward. So you get more sensing in the front of the car where you're usually going to be traveling. Those cameras, those video feeds are then augmented with LiDARs and radars, which sort of measure directly sort of the 3D geometry of the world around you, and is often visualized in sort of like point clouds like this. And then also another important sensor is, of course, GPS and IMUs, inertial measurement units, which are used to help figure out the motion and position of the car. But the main sensor is the camera, and is the main one I want to talk about here, and sort of is the segue to the first maybe issue we can talk about. And it's the issue of privacy. So these cars are outfitted with a ton of cameras, constantly recording information, and as a result, they are constantly recording people in public spaces. And so they're not just taking that information, those video feeds, turning it into motor controls, and then discarding it. This data is logged and aggregated by AV companies in order to do a lot of things. One of the main ones is produce more training data for their algorithms. And also, since at least some of these vehicles do need to be able to kind of phone home and ask for help, the data can also be remotely sent off the vehicles almost live back to data centers. And so the result is that if these vehicles become widespread, then AV companies will effectively be doing live surveillance of entire cities. And I think right now in sort of the popular media, maybe that isn't discussed a lot. But it did remind me of a similar thing that happened in the last, maybe 4 or 5 years, which is when Amazon released these Ring cameras, these doorbell cameras that are, supposed to help prevent crime. And the public reaction to these was, I'd say poor is maybe an understatement. People do not like finding out that they are being surveilled in public places, and they especially don't like it when that's being done by private companies. So here are some articles from some popular media, the Guardian and Vox, about some lawsuits. And then there was also this FTC consumer advice column that specifically went into a lot of the issues that can come up when private companies end up in the business of mass surveillance. So that is sort of the first section, the sensing section, the first maybe issue we can talk about. But now we're going to sort of quickly move on to the next one in the interest of time, which is the perception part of the stack. Okay, so perception takes those raw sensor measurements and needs to deduce things about the world from that. The first thing you need to figure out is the so-called localization problem. You need to be able to answer the question of where am I? Where is the vehicle in space? That's mostly done using GPS, same as we all do when we drive around with Google Maps. But the accuracy required is more than what you can get with GPS. And so these companies generally also rely on what are basically high-resolution 3D models of the cities that they operate in. And those models have annotations on them about like the lane markers, where signs are, where traffic lights are, things like that. This is another reason why the data they collect can't just be discarded. It's used to keep these maps up to date. Now, the other problem, the one that we're going to talk about a little bit more, is answering the question of where is everything else? You have to know where all the other people on the road are as well as where you are. And that's mainly solved through this sort of tracking and detection paradigm, where you detect in your video feeds and your LiDAR point clouds, what are all of the other things on the road around me, and then you associate those detections over time. You form tracks of their motion. And so at a very, very high level, the way this works is you get humans to draw boxes around a set of classes of things that you've determined are important for your vehicle to be aware of. And then you train your machine learning algorithms to essentially recreate those boxes. And so this is the main more AI component of this task. And so that's the one we're going to talk about. And the sort of the provocation I have for this, or the problem I have with this, is this question of what they call the long tail. So here is a bit of a bar graph from Argo, from a data set that they released, showing the sort of number of instances of different things that the vehicle needs to be aware of on the road. And obviously, the main two things you got to be aware of are vehicles and pedestrians, which are these two bars. So for vehicles, you can see you got about 5 million or 50 million in this data set, and about 20 million, 5 million and about 2 million pedestrians. But then there's many, many other things that are much more rare, but nevertheless are important to be aware of. And this is what's called the long tail. So if you look all the way over on the right, you'll see the animal class. That's, like a wild animal that strays into the road. And you can see that there's only about 200 examples of the animal class in this data set compared to 5 million for vehicles. And so this long tail causes a lot of problems, not just for training algorithms. Of course, it's very difficult to train your machine learning algorithms to work well when you have a very limited amount of data. But it also makes it very difficult to evaluate your models. It's hard to know how your vehicle will react to a deer running in front of your car when you've only seen that happen 3 times in the entire recorded data that you have from your fleet. And so this difficulty of understanding, sort of evaluating and understanding how these vehicles operate brings me to the final portion, which is about the planning portion of the pipeline. So once you've done this, once you've taken your sensor measurements and you've turned them into things like object tracks, and you know where you are in this high resolution map, you can kind of think of the world as operating in this really simplified way, where you have all the lanes, you know where you are, you know where everything else is, and you have tracks of their motion for maybe the past, I don't know, 10 or 20 seconds. And then your goal here would be to make some tentative plan for the motion of the vehicle over the next 10 seconds. And just like with the perception problems, generally these algorithms work by driving all these routes, having a human drive these routes, labeling all the motions of all the actors, and then training a model to predict these plans, which also involves predicting the motion of all the other actors in the scene. But the big problem here, which is very different from the task of just sort of drawing boxes around all the other cars, is that there's feedback between the motion plan of the AV and all the other actors. And this can't be captured in pre-recorded data. So I'm going to zoom in on the scenario on the right here. What's happening here is that the vehicle is making an unprotected left turn. This is a left turn where you need to turn into traffic. So you're crossing another stream of traffic that's coming at you. And, as we all know from driving, this requires sort of like edging into the intersection, waiting until, other people see you and slow down, and then safely continuing through the intersection. And so any algorithm that's going to do this same process kind of needs to have some sort of, theory of mind about all the other actors in the scene. And importantly, you can't really evaluate performance on this task by just replaying old data. You can't figure out if your car will safely turn into an intersection and make an unprotected left turn because all you've recorded is what humans did in that exact scenario. You don't know how they would have reacted to a different plan proposed by your algorithm. So the hope is that, if you get enough data of human drivers, then you still are just effectively able to do this. But there's still this question, and it's the question I want to end on, which is, like, how do we know if these work? How do we know if autonomous vehicles are safe and work? And the answer to that right now, and I think I can say that kind of the only answer we're ever going to get is, because we tried and nothing too horrible happened. There really isn't a way of taking these things apart and testing all of the components in such a way that you can determine that the final product is completely safe and you know exactly how it's going to react in any situation. We're forced to put these things on the road in real scenarios and see how they perform, hopefully with appropriate safety precautions in place. And, of course, obviously these companies have permission from local municipalities to be doing this. But in effect, what's happening is that, regular pedestrians and motorists are taking part in an experiment when they drive and walk around these vehicles in public. And I'm not entirely sure how aware most people are of that fact as they're doing this. And I could not see the time when I was doing that. I think maybe I've already run a little bit over. So with that, I will hand things over. Thank you.
Okay, I think I'm off mute. Do you hear me? Terrific. Okay, thank you. Nathaniel, you just covered a bunch of the area that I had hoped to cover as well. So that should shorten things a little bit. Thank you, Mona, for this invitation. And I'm delighted to be here with Nate and MC as well for this conversation. So for my comments today, I want to share a bit of, I'm going to replay just a little bit of what Nate just covered in terms of how AI shows up in autonomous vehicles. But then I'm going to raise 3 brief provocations to consider more in social terms what it might mean to have these vehicles in our midst. Just to set some context, as I was introduced, I am an anthropologist and I've long worked at the intersection of complex technology development and the sort of social and user impact, and especially around automated and complex technologies, both in work settings and then for the last decade in autonomous vehicles. So Nate just took us through the architecture system of an AV, and I'm sharing this again just to say, as an anthropologist who's worked in these complex autonomy settings, these kinds of system architectures, some of my colleagues and I have come to sort of see as the iconic images of developers in labs, in computers, high tech and computer settings. So we kind of read them as we would any other cultural object and are fascinated by them in that kind of way. As you see here, this one is a rather old one from my time at Nissan. And it covers many of the same categories with some variation as to how much detail you're showing and what it means. And then here's another image. This one is taken from a very old online YouTube video from David Silver, who went on to teach the autonomous vehicle training for one of the on Coursera, I think. And made up, as we just covered, with sensing and perceiving, predicting, planning, and deciding, and acting and controlling. So I won't take us back through what all of those are, but I do want to just point out a few things. First of all, the way that different developers handle these and different manufacturers sort of work through the details underlying them are, of course, very different from, that's where the secret sauce, so to speak, for the developers would be as to what are the different kinds of models and approaches that they might use. As Nate just really appropriately laid out, one of the challenges in that sort of sensing to perceiving and then, on to predicting area is the question of what gets labeled and classified, where you get that bounding box. And the challenges of, what does it mean if we leave out some of the smaller data set items, but that are consequential and would be immediately recognizable in human terms as significant to the setting, but they're just less frequent. And so the possibilities of what happens in that part of this, and I'm looking sort of on the left-hand side as we move towards the middle, are really endless, but the model parameters and the compute requirements for the more that you include are also really costly. So the developers are having to make decisions about how far down that path they go. Then when we move over to the right-hand side, this is where I've experienced in the labs that I've worked in, and I have worked both at Nissan-Renault, which is a personal car company trying to do more like Tesla might be doing, evolve autonomous vehicles out of your standard personal car, going through, for those who know the lingo, the different levels of autonomy. I've also worked for Waymo, which is instead taking the track of going all the way to the far end of autonomy, the level 4, level 5, and operating the vehicles as robo-taxis, as a service in that transportation area. So these are really two quite strongly different approaches, but in both cases, that sort of right-hand side, more towards the planning and decision-making is has been, I think, my experience so far, sort of, again, the sweet sauce, or where there's so much focus around where the intelligence lies. I will also just say, so I've made one contrast in the industry between the sort of, do we take the route all the way through personal cars, or any of us as individuals going to walk out our door and get into a car that is able to drive completely by itself, compared to those who are developing them for fleet services. Another contrast that I've seen that I think plays a role in terms of translatability and explainability of the systems are labs that are using more of the machine learning, deep neural net kind of approaches, what we typically think of as AI, and those who maybe come from more traditional AI arenas, working with Markov decision models, partially observable decision models, partly based on the desire to have a clear, demonstrable, retraceable path as to what's happened in the system. So there's a lot of variety of how the systems are being developed and what's happening behind the scenes. So that's a little bit of context. Let me now move on to 3 different provocations. My first provocation is to suggest that we're really at a design inflection point, and this is one of my favorite soapbox items because I'm afraid that the industry is going to very quickly move forward to move past this without due care as to what it might mean to not stop and consider this design reflection point. So what do I mean by this? Essentially, for autonomous driving to make inroads, and for the developers to be able to scale to success, as Nate just took us through, the prevailing view is that it's really important to get the cars on the road soon, to get as many miles driven, both in real miles and then all the permutations that happen in simulation, and to acclimate to have people having them in their midst. There's no way we're ever going to have autonomous driving by turning on a light switch. It's unavoidable that it's going to be a slow march of increasing advancement and scaling of having the cars out there. So a key imperative has been to make sure that they can fit into today's world, driving in such a way that they don't interrupt or interfere with people's expectations and practices today. One of Nate's examples was the left-hand turn, where the assumption is we do need to start inching into the intersection to begin our turn so that we're poised and ready to go as soon as we possibly can. And to be frank, a lot of my work as an anthropologist and as a social scientist in these companies in this area has been to help establish and identify what are those expectations and what are the varied practices in different settings around vehicle behavior in today's world so that we can design them accordingly. But if I put this provocation another way, I'm asserting that the human-like AI for driving is really a red herring. Should AV replicate what happens today on the road, or should we just let robots be robots? Maybe this kind of WYSIWYG approach to autonomous driving is going to have a net effect of recreating today's traffic and driving behavior, warts and all. So if we zoom out 10 to 15 years, do we not end up with the exact same experience on the roads that we've always had, except for there's no human drivers in the seat? Isn't there a chance instead to actually make for a better roadway experience? And yet I totally acknowledge that this red herring is really a catch-22, just to roll out as many cliches as I can, for the industry. How do you make advancement without trying to get onto the road today? So as Nate also indicated, there's no avoiding the fact that autonomous vehicles will shape public experience. In a way, everybody becomes a user. They become impelled and compelled into the setting by crossing the street, by being on a bike and being overtaken by a car, by stopping at an intersection with an autonomous vehicle. And so inevitably, there's going to be these interactions. And as Nate said, do we even know how aware people are or will become? And these experiences shape our experience of the public. So this then brings me to my second provocation, and that is that interactions matter. Now, this may be no surprise coming from an anthropologist to suggest that I might think this to be the case, but I think there's a lot of ways that we want to think about this. So Jonathan Shapiro-Anjaria, in a recent ethnography of bicycling in Mumbai, called Mumbai on Two Wheels, argues that attending to road surfaces in Mumbai among bicyclists is more important to bicycling than the specialized bicycle infrastructure. So what he's looking at is how people, sort of the traffic planners, sustainability folks, are thinking that you need to do major infrastructural change. You have to add bike lanes and things like that in Mumbai. And that his ethnography reveals that what people really care about is the nature of the surface of the road, how it's maintained, and who the users of the road are. So there's a politics here over for whom the roads exist and how they get used, shared, and maintained. And as we see in his quote here, this politics, it takes us to a kind of micro-politics. While revealing the hidden meaning, sorry, whoops, didn't mean to go there. Sorry, let me move my illustrator around here. While revealing hidden meaning and going beneath the surface to expose power relations that structured the city are important, here he's arguing with a sense of a kind of hermeneutics of suspicion that social scientists tend to bring by looking for deep structures of things. They are not the only ways to challenge the status quo. Attending to the surface can really bring us into a politics and a micro-politics. So for myself, it's rather than attending to street surfaces, I'm attending to the interactional spaces. Interactions are everywhere in road use. They're in and it's the public space of the street, the curb, crosswalks, and so on that we really deploy our resources as citizens to attention, to care, to politeness, to norms and conventions of interaction, perhaps to indifference, all of these about being how we've come to expect and understand that we interact with fellow strangers in public. So let's look at some of how this happens today. Here's a typical street scene, perhaps, in a small Northern California town, a small downtown. It's a nice pedestrian area. We have large bulb outs. We have clear crossing. And we see normal interactions. Now, if you watch what happens here with this white car and that pedestrian, a little interactional moment of conflict. Meanwhile, that Jeep and the white car had to figure out their crossing order, who went first. And we have these pedestrians on the right who had to stop and interact with that vehicle to determine the turn area. So I'll go ahead and let this play while I talk. So if you didn't get that, you can watch it again. So let's imagine we've arrived at a future where some, if not many, of these interactions are with driverless cars. Where does the accountability fall in enabling these kinds of interactions? And this is what takes me back to that worry about human-like driving. If we're optimizing on the behaviors that are leading towards keeping the flow going and not impeding the other vehicle traffic, of making a traverse as soon as possible so that we don't hold up lines and all that, then aren't we recreating the same exact sort of street functioning as we see today? And it's a risk. Sorry, I keep hitting my wrong buttons here on my side. So this is a risk that mirrors in many ways what Madeline Eilish has called the moral crumple zone, that we're creating a space in which the interactional troubles on the roads may well be blamed on the individuals, that the individuals haven't learned and been disciplined into behaving in ways expected by the vehicular traffic. We know the history of jaywalking, that it was the car companies that advocated for jaywalking to be law, to discipline the walkers, to make sure the walkers stay in their right zone, behave and move when they are instructed to move, sort of taking the roads, which have a much longer history than vehicle traffic, and reshaping them into roads for vehicles. But there are other possibilities, and actually I'm going to advocate on behalf of saying that autonomous vehicles ultimately can have a positive effect here. One is that we default to behavior designs that are less likely to aggressively force those kinds of interactions to begin with. This is where we maybe lighten up on the human-like approach to driving. The white car that we saw in conflict before maybe would wait a lot longer before it starts to turn. The cars waiting for a pedestrian to cross maybe don't start to roll forward and create that kind of anxiety of, oh, I need to move quickly because I'm holding somebody up. Another possibility is that while there's a lot of hubris around the sort of collaboration and mutuality in human-robot interaction, let's not overlook that robot cars are themselves entering into areas of sociality where the interactions are really fleeting and they are interactions among strangers. There's sociality for sure, but it's fleeting and brief. This is not a site of active teaming and deep collaboration. So one of the ways that we might be able to support these kinds of interactions is by adding different signals and communications to cars. These are some of the things I've tested and worked on in the companies I've been in, that the car could do things like be able to say, I'm stopped and I'm staying stopped, as a cue to a pedestrian that you can go. And one of my sort of crowning moments in this kind of work was when I ran some tests with pedestrians actually in a city setting, but sort of over to the side, but on real streets. And one of our test participants, as they were walking away, long after we had stopped our discussion and interviews, sort of said, it really felt like it was giving something back. Like they were having a new connection to this interaction with a vehicle. And this then brings me to my third and final provocation. The roads are not equal today. The roads do not provide equal access to public engagement. So in this provocation, Mona, I'm taking you up and I'm going to disagree with the assertion of the session that transportation enables citizens to participate in democratic processes by providing equal access to public spaces, resources, and civic opportunities. The roads aren't equal today. They're indeed designed for a bias towards vehicular traffic. And more than that, the foibles and the distractions and the variations of human driving styles. As we saw in the earlier video, there are clearly many moves afoot to make the streets more compatible to pedestrians and to bicycles, like the bulb outs, different sort of transit and sort of infrastructural moves. We have in mass transit, we have things like public transportation regulated by vehicle governors to control speed, by regulation as to what they're actually doing. But having spent loads of time as a researcher with pedestrians, with bicyclists, with people with mobility and vision disabilities on the road, with young families, with kids in strollers, with elderly who move more slowly, with distracted college students trying to get to class, it's clear to me that we've simply come to naturalize and accept the anxieties and risks of everyday road use. It could be different. In fact, it has been different. This is a video from San Francisco before the big earthquake. It's called A Trip Down Market Street in 1906. And this is how the traffic moved and how it functioned at that time. So this just reminds us it was different. It will continue to be dynamic and emergent and be different again. So if we reset our lens of political action, then there is indeed, to echo Jonathan Shapiro Anjaria, a surface politics to be had here, and actually AV may actually contribute to us making the roads a sort of more equitable and more evenly dispersed in terms of who is in control of the kinds of interactions and who can affect them. So finally, I would argue or ask, is it ethical not to proceed when the roads and public spaces that we have today are already imbalanced to favor some and not others? So with that, I'm delighted to hand over to MC.
All right, let me do the usual dance of figuring out how to share my slides and presentation, please. Cool. Awesome. Well, I'm very excited to be closing this out. I am extremely pleased to be invited into this space because I think I take an approach to autonomous vehicles that is often underrepresented in that I don't talk about autonomous vehicle design or designers, but I talk about the sort of world that exists around them. So taking an approach from both science and technology studies and a sort of burgeoning interest in de and post-coloniality, I study repair. I study what happens to these cars, what sort of networks that they enter into as they're being designed and built, and what networks they enter into as they go out of use, and and the sort of problems with that. Now, the keen-eared audience member might note that the problems I'm discussing are not limited to autonomous vehicles. When I started doing this work, it was in 2017, with which, as Nathaniel mentioned, was just the early days of AV as a trend. And I learned very quickly that the only way to get people to listen to my concerns about automotive design was to make sure that I was talking about autonomous vehicles. But these concerns are by no means limited to autonomous vehicles, and I'll explain that in a bit more detail. So I'm going to have to ask Nathaniel for his image, because the image I use to talk about the sort of the complexity of the contemporary car is clearly a little bit out of date. So this is an image I use to just explain to folks what are all the software-enabled and sensor-enabled systems that exist on contemporary cars. And so they are some things that are very, very basic, like windshield wiper control. There are some things that are much more complex, like adaptive cruise control and things like that. And this is, again, an image that is a few years old. So at this point, you can imagine how many more software-enabled and sensor-enabled systems exist on a car. And the purpose of illustrating this is just to really impress upon folks how sophisticated these artifacts are as computerized systems, right? And this can be very exciting from a design point of view, and it can be a source of enormous potential, but it also, that sophistication and that complexity also creates enormous problems both up and downstream. And what I'll be talking about today is the sort of general category of the software-enabled or software-defined vehicle, the SDV, which is at least when I was reading about this a few months ago, was the parlance commonly used by automotive manufacturers to talk about their vehicles not exclusively enabled by artificial intelligence. It includes artificial intelligence, but it also includes just like high levels of computational sophistication. So basically anything that runs on an operating system in the car is part of the software-defined vehicle. And these are trends that are becoming extremely prevalent. I almost needless to say, in the automotive industry. So, including some very, very interesting um, partnerships and trends that I've been trying to track. And I'd be curious to talk with folks who know more about it between traditional automotive manufacturers and um, companies that more typically served the personal electronics or enterprise electronics spaces. So these are chip manufacturers and chip designers like Qualcomm. So Stellantis was partnering with Qualcomm some time ago to help develop its software platform. Some manufacturers have announced bringing that work in-house and deciding to do their chip design and chip manufacturing in-house, which I thought was really interesting. A project that I would love to pursue, but would need a partner in so doing, would be looking at how these sort of traditional automotive firms are evolving as they begin to integrate more and more software development, computer engineering, things like that. These parts of the industry or parts of another industry that come from very different sort of educational lineages, different sorts of industry cultures, attitudes, and conventions of quality assurance and safety testing and things like that. So how is the traditional automotive industry and computer development, software development, how are those cultures sort of integrating into one another? But there are some signs that it is a rough road, pun intended. Um, but this is important because this is where the industry sees most of its value coming from in the near future, right? And so when we talk about like autonomous driving and advanced driver assistance systems, so autonomous driving, sort of, we know what that is, but advanced driver assistance systems are the other parts of the software platform that I was talking about before, not necessarily AI, but very software driven. And they think that consumer demand is going to grow for these kinds of features. They think market share is going to grow for these kinds of features, right? And I'm always interested in these models because I think the sort of modeling that determines industry trends is something that I don't understand very well, given my background, because it seems like sometimes the tail is wagging the dog. But this just serves to demonstrate that this is where car manufacturers are investing their energy because they see that this is where the industry is going. This is happening at the same time as really interesting things are happening in the policy space. So one of the sort of hallmarks of the software-defined vehicle, and I think of most AI-enabled vehicles, although I encourage my panel mates to correct me on this, is that they tend to be electric vehicles as well, or at the very least hybrid. And so at the same time that this move is going towards the software-defined vehicle, we're also seeing policy moves towards banning internal combustion engines as well. So further supporting the sort of drive. Human or English language is like just rife with automotive puns. So I'm going to stop saying pun intended. I almost can't avoid it. But this drive towards the increasing investment in software-defined vehicles. So the entire west coast of the United States at this point has banned the sale of internal combustion engines starting in 2035. Major parts of the EU, although I understand that this is a little complicated right now, have done the same. Parts of Australia, and this is more on a state-by-state basis than it is a federal basis. And as well as other parts of the world, right, are starting to really move on banning internal combustion engines. So further fueling, pun intended, the sort of expansion of software-defined vehicles. My particular interest in this is in repair, because one of the things that a lot of these policies take into account when they're proposing or defending these bans is that, among other things, among the other calculations they make in terms of safety, in terms of emissions and things like that, are that these electric vehicles, these software-defined vehicles, will have uh, consumer benefits when it comes to the lower costs of repairs. And they say that this is true because electric vehicles have fewer parts than an internal combustion engine does. Those parts experience less literally combustive um, stress than internal combustion engines do. And so they anticipate that they will require fewer repairs. Now, this is all based on modeling because electric vehicles have not been around quite long enough for us to really have a clear picture of how much less they cost to repair. Like they've been around for about 20 years at this point. And so we're going to get a better picture of repair costs in the longer term. The other problem with those models for repair, and I forget if this is my next slide, but something Melissa said reminded me of this. No, all right, we'll get to that in a second. Is that these models take into account parts but not labor. And I will put a pin in that later. I have very, very serious concerns about the labor required to maintain and repair AI-driven or software-defined vehicles. And so this is partially because software-defined vehicles have so many moving parts to them. Again, I'm going to have to update this, but as Nathaniel mentioned, they have a number of sensors on them. So AI vehicles have fewer, but the current software-defined vehicle has radar, LiDAR, cameras, some limited ultrasound, right? And these all require different sensors located all across the car. And those sensors, if anything happens to your car, your automotive technician has to figure out which sensor was damaged, and then where that sensor was located, how to source a replacement sensor. And all of these can differ across make, model, year, and sometimes factory of manufacture or month of manufacture. So if this is a real concern for the independent repair industry, because the effort it takes to find that information is non-trivial. And moreover, it probably doesn't surprise anybody here, but automotive manufacturers are very proprietary about that information. They don't share it widely. And so it can often be very time consuming for independent repair shops to find that information. Moreover, even if you manage to find the parts and do the repairs and things like that, then you also have to then recalibrate the systems, right? And this will be true of AI systems. This is true of software-defined systems, right? You put the parts in, and then you have to make sure that the parts are communicating to each other accurately. And in order to do that right now, most repair shops use a series of targets, visual targets, that they test the sensors on to make sure that the sensors are communicating properly. These targets also vary by make, model, and year. So this is, again, another like financial investment that independent repair shops have to make, in addition to requiring different amounts of space. So for example, some luxury manufacturers require 35 feet ahead of the car and 45 feet wide in front of the car of unobstructed space in order to recalibrate to targets. I used to live in Brooklyn before I lived in Charlottesville, and you might imagine that it's very difficult to find 35 feet ahead of you and 45 feet wide in front of you of unobstructed space to do automotive repairs in Brooklyn. So this is a real challenge for repair shops in urban spaces. It's a real challenge for independent repair shops just in general. And so in addition to these costs of what it will take to repair AI vehicles, even on the best day, is the labor problem that I promised we'd return to, which is that we simply do not have the labor workforce currently. It's incredibly difficult for trade and vocational schools to update their curricula to keep up with the new systems that are coming out from automotive manufacturers. There are very few resources available to them through the federal or state governments to do that work. And it's gotten to the point where, for example, at the very beginning of this year, Hertz the rental car company, had to get rid of 20,000 of their Tesla cars because they did not have the maintenance labor to maintain that fleet, right? And so they had to sell off 20,000 cars. So this is a real concern. If we're building these AI-driven vehicles, are we also developing the repair and maintenance infrastructure necessary to keep them on the road? This is also a huge problem when it comes to manufacturing, but it's a repair problem as well, right? Where the complexity of the supply chain that makes these parts possible to build is going to be an issue, right? And so these are parts for manufacture and also for repair. This was a problem during the pandemic when the chip shortages created incredible delays in automotive manufacturing and repair. And it's hilarious because I used this article that was almost 2 years, published 2 years ago to the day. But then we have yesterday the news that China is restricting or completely banning the sale of critical minerals to the United States, which is again going to create a bottleneck in manufacturing capacity for parts used in manufacturing and repair of these materials. And this is a problem when we're talking about an infrastructure that is as necessary as the transportation infrastructure is, because we haven't provided American citizens with transportation alternatives. And so my concern is that we're going to see a change in what has been over the last decades, an upward trajectory in the longevity of cars that are on the road. As of the last statistics I could get my hands on, 2017, the cars on the road are the oldest they have ever been in the history of us recording that. But if we look at the way that other software-driven consumer electronics go in terms of like how long they last, how long they can be maintained, we see downward trajectories. So this is smartphones as an example. I'm concerned that we're going to see similar trends with cars as cars become smartphones on wheels, as many people in the industry like to say. And then this is my particular bugaboo. The more we make drivers feel safe because of their cars, like the safer we make cars for drivers, and we've made huge gains in terms of passenger safety in cars. We've had fewer fatalities for people driving in cars in the last 4 or 5 years than we have in decades. But that is fueling this really interesting concurrent trend where we're also making cars bigger. Pickup trucks are my particular bête noire, but we're seeing this sort of across the industry. And then there are all the other things that the integration of AI and software-enabled features also allows. So if you're interested, I have an article coming out in Engaging Science, Technology, and Society on how subscriptions are a sort of a parasite piggybacking on the like AI trend in vehicles. There's also real concerns with how software is regulated in the United States and whether or not they're going to automotive manufacturers are going to use some of those loopholes to undermine the right to repair in the United States. So in conclusion, I guess I have a lot of provocations here, but my concerns are that EVs, SDVs, AI are often seen as a climate change panacea or a driver security panacea. But I think there are some real concerns in the broader ecosystem of like what it takes to have an automotive infrastructure that are not being considered as we hurtle towards these increasingly sophisticated, proprietary, and mercurial technologies, right? Are we building repair ecosystem capacities? Are we building long-term support for operating systems and hardware? And are we taking, is all the money that we're investing in these technologies perhaps better used for alternative transportation solutions? I want a monorail. Every city should have a tram, you know? And so I think that is where I will leave it. Thank you.
Thank you so much, Nathaniel, Melissa, and MC, for these wonderful provocations. This is the call for the audience to start putting questions into the Q&A box at the bottom of your screen. We already received some questions, and I will get to those in a minute, but I'm going to take chair's privilege and ask the first question. So in my mind, we've heard actually a lot about the relationship between people, AI, and the future. Nathaniel, you talked about the question, what does it mean to know if an AAV actually works? And the sort of topic of prediction and benchmark sort of was in there, and a very interesting point. Melissa, your point about the inflection point really struck a chord with me, and the big question, how do we even imagine the future, and how do we want to imagine the future? What kind of assumptions and interpretations do we bring to the table when we look at how roads are today? Are they even equal? Are they actually an infrastructure for democracy or not? And if so, in what way? So there was a little bit about where do we want to go? What do we want to optimize for? And then MC, of course, your point about repair the human aspect, the material aspects of that. What kinds of things do we need to plan for as we enact this vision of a greener future by way of AI-driven electric vehicles? So future kind of was a big topic, I felt, in these presentations. Now, super sweet and short from each of you. I'd love to hear, and I mean the short bit because we want to get to the audience. Why have we, for the longest time, envisioned our technological future through cars and vehicles? And not just the imagination, but we've also seen an advancement of various AI technologies. Nathaniel spoke about sensing, right? Through actually acting on that in the context of cars, of vehicles. It's this this important aspect, both in terms of imagination and in terms of technological development, I think. So the future of our technologized society is entangled with cars. Nathaniel, Melissa, and MC, why? How do we get to this point? Very briefly.
Neoliberal capitalism? Like the history of cars is a demonstration that, as Melissa referred to, that like a lot of the changes in the infrastructures we've developed have been on the whims of certain capitalists who could shape policy, and policy shapes, cultural life, and cultural life then shapes markets and so on and so forth. But moved often by the interests of industrialists and capitalists.
Melissa, Nathaniel.
Yeah, I'll just say I don't disagree that that's a large portion of how we get there, the broader sort of political economy of these things. I will say I've come to truly appreciate that there are dimensions of the automobile experience. I'm betting most of us, if not all of us, have cars or have driven cars or use cars. It's that there are aspects of what it affords and what kind of travel this is that isn't afforded through other means. And so the draw and the use is hard to simply just sort of ignore. And I know some people who don't drive or don't use cars for sure, but it's a rare bird, and I think there are some reasons for that.
Yeah, definitely piggybacking on what Melissa just said. I mean, I think cars are like a fundamental part of American culture. I think individual car ownership and the autonomy it allows is it's like almost an embodiment of American individualism. And I don't see that going away. And I don't think people would want it to go away. And I think that's definitely another huge driver for why we imagine the future of transportation as being more advanced cars instead of other things. But I rode the train here today.
Haha, there we go. Thank you so much. We're going to turn to the audience, and this is again a call for audience members to put their questions into the Q&A box. Nathaniel, I'm gonna stay with you with a question that's coming from Lily Chumley, and they're asking, with respect to difficult practical problems, you just have to try to do visibly autonomous vehicles do better or worse than more subtly autonomous vehicles? Question mark. If so, is that because other drivers respond differently to those two types of vehicles? I'm wondering if cameras and branding operate much like a quote unquote new driver bumper sticker in changing the pragmatics and etiquette expectations of other drivers. So the practice of driving is the focus of this question here, Nathaniel.
Really interesting. So I think the question is asking sort of is part of the difference in quality between maybe a Waymo taxi and your BMW that has like advanced driver assist, part of the fact that people see the fancy cameras, they see the branding, and they react differently to those cars. So that's really interesting. I definitely don't have any hard numbers that say anything about this. What I can say is that definitely some of the issues related to full autonomy is the way people react to them. I think there was like a long string of news articles of people doing various things to abuse Waymo taxis in some sort of, I don't know, hope of striking back maybe against the company. So yeah, I would say at least to some extent, yes, the obvious branding of full autonomous vehicles makes them a little bit harder to operate than the more subtle things.
Thank you, Nathaniel. We're gonna stay with the practice of driving as sort of a little bit of a frame. Melissa, I have a question for you from Martha Bird. How do you envision a different way for including all citizens, especially those without access to private driving agencies, I guess, in the project of autonomous driving?
Yeah, thank you, Martha, for that question. I think my frame would be that all anybody who's in an urban environment where there's movement on roads is already in the bucket of how people would be included. So I don't know if you're especially interested in those who actually have to get inside of these vehicles, and I do think that that's another question. That's back to are we talking about people operating their own vehicle with autonomy or using a service like a Waymo, which is basically an Uber Lyft type situation without the driver in the seat. And then those become questions of pricing, business models, where the vehicles are, effectively able to go and not, which, by the way, is one of the challenges with any other form of public transit that, there are those constraints. There's always that last mile problem of what about the getting to and from where the transportation goes. So, I don't think that there's anything distinctive about autonomy in that scene of access to transportation per se, except for the ability of the vehicles to go all the different places. Then the users on the road and the pedestrians, the bicyclists, the kids in strollers and on tricycles, the animals, whether they're on a leash or not. That's where I do think, this attention to how are we imagining the behavior and really taking into account all that is there. And I remain or try to remain optimistic that we have a better shot at that actually with some of this technology than perhaps without.
That's great. MC, really briefly, because I have a question for you following up.
Yeah, I think one thing that we could pay attention to is maybe what the government is funding in terms of research. That is one way that citizens could somehow get involved. I know that there are a number of universities that have very, very well funded like autonomous or autonomous driving or AI driven like vehicle research arms. And I'm wondering if research would find that there's the same amount of funding being granted to alternatives to that, right? What are we prioritizing as a country in terms of our public funding? And how can citizens get involved in shaping that?
Yeah, that's a very interesting point. And I'll get back to that because I do have a question about sort of urban and rural in this context, actually. But I have a question for you, MC, from Andrés Sobral, who is in our team, actually, at the DTD at UA Karsh. And he would like to know how we can evaluate and recognize the role of collective labor hidden in AI technologies, including how cars have been trained by real drivers, and how a workforce is necessary to manually control the cars in more than rare breakdown circumstances. Are we seeing mechanical Turks being sold as high-tech future? Can we expect some kind of AI devoted to public transportation instead of individual profit?
I might actually defer this question to Melissa because I think that she would have a more particular answer because I have not been embedded in the car companies. I don't know how they're approaching this. I would love to learn more. My focus is more on like how we are training the labor that takes care of like the cars after they've experienced that breakdown. But I'm not really familiar with how we're training the models themselves. So I will defer this question.
I'm happy to speak to it, and then I'm sure Nate may also have something to add. I think it's a great question, and the ghost labor that goes into any of these vision models that are, where do you think the labelers are sitting for, informing the models to begin with? All the sort of labeling classification is going to be very often sort of offshore, massive sort of armies of I presume not very highly paid workers. Another interesting arena for the labor is, again, in the fleet operators, so not necessarily the personal car model, but the fleet operation model like a Waymo or a Zoox or some of those would be the labor involved in those who are providing remote supervision and roadside assistance. So the remote supervision, which it goes beyond just a passive supervising. It can be, helping a car that's in trouble based on sitting in a control room and observing that. There's some variety of the kinds of skills and labor that goes into that aspect of things. But it's not that uncommon to have somebody like a taxi driver say, my future job 10 years from now, 20 years from now, will be sitting in one of those control centers, not behind the wheel. And then all the sort of depot operations. I think before we get MC to your really important and interesting dimensions of the repair, but even just the kind of operations within any of these fleets and what's happening there. Again, I don't think any of those are going to be they're not the same pay rates and scale, this sort of barbell economy that's increasingly emerging between the very highly paid, fewer numbers of people and the many more lower paid people performing those sort of service tasks are some of the things that come to mind for me.
Nathaniel.
Just add a little bit to that. So in terms of labeling, yes, that there's a huge amount of labor involved in producing all the labels that you need to train these algorithms, as well as labor required to do the human drives that then maybe you hope to copy behavior from. I'll say that my observation of these things has been that that's not, it's definitely part of that is like outsourced labor. It's not the sort of bottom of the barrel outsourced label maybe you're imagining. This work, it can actually get quite technical and challenging. So I know Argo actually had a completely in-house team do all of their laboring located in Pittsburgh, since it required a lot of training of the people to get high quality labels. And then in terms of the the mechanical Turk question about is this really AI or are these sort of things being just driven remotely? And so I can definitely say that that's not true. You can't drive a car remotely over like a 5G connection. The latency is too high. But yes, you definitely do need people sitting in call centers being able to label bits of the road and say it's safe to proceed in situations like that.
Thank you, Melissa.
Yeah,
Last word to you.
Yeah, to add to that, and I agree. Thank you, Nate, for clarifying. There's no remote driving happening. There's no joysticking or anything like that. But the possibility that that you are giving a command to a car that says, no, that really isn't a distinctive obstruction, you're free to go, and then the car continues in its autonomous mode. It's that kind of labor. And then those are still very skilled. And even the role of the driver training, I didn't address that. You know, the driver training of the models is, as Nate pointed out, really important, but it's not the only thing. I would argue that the simulation side of the house is equally and as important, and perhaps more. So you start with the driver training and what actual drivers have done, and then you do a gazillion permutations of all sorts of different possibilities. And then you arrive at the conditionality problem that Nate raised, which is then you don't actually know what would have happened from the other agents on the road, given what you've now performed. But that kind of simulation work, again, then is another site for some quite advanced and sophisticated labor, at least at this stage.
Thank you for these clarifications. I think we've learned so much about what autonomous vehicles do, how they do it, where these technologies come from, where the imaginations come from, what this means for the social fabric that is not just on the road, but everywhere, how we think about future mobility, labor, all these kinds of things. So I think it is fair to say that Karsh is a really productive theme for understanding a little bit more what is going on in our AI-infused society. So with that, I want to extend my sincere thanks to Nathaniel Karsh, to Melissa Cefkin, and MC Farrell for their amazing contributions. I've learned so much. You can find their stuff online. It is amazing. They have many more interesting things to say. I encourage you to do that. Again, big thanks also to our teams at NYU and of course at UVA for their work. This is the last event of 2024. We're done for the year. We will be back in 2025 with more co-opting AI conversations, and we have really exciting themes on the docket. We will be talking about privacy, about museums, about violence, about antiquity, education, and maybe about taxes. So stay tuned for that. I wish you all a wonderful holiday season. Get some rest. It was great to have you in 2024, and we'll see you next year. Thank you so much, everyone. Take good care. Goodbye.